The space system, or the ability to find one's way, that evolved very early in evolution because every animal is dependent on it. You can't survive without, right? But now artificial intelligence is evolving so fast that we are, in a way, a little bit behind.
The nation sits down with Professor Edvard Moser, Nobel Laureate in Medicine, to discuss the location system in the human brain and whether it can lead to a cure for Alzheimer's disease.
So you're in Thailand for the ASEAN Bridges series event. And because it's facilitated by the International Peace Foundation, I probably have to ask you, how do you see neuroscience work with the peace-building process?
Neuroscience is like any other science. Science is an international endeavor. People work together all over the world to solve the same problems. So in neuroscience, to find out how the brain works and do that in order to treat diseases that exist all over the world. So the fact that people from all countries work together to do something, achieve something, is one way to create peace, because you come together in a positive way instead of fighting and obtaining things only for yourself. That is one aspect of science. In a more broader sense, I think both science and education, which go hand in hand, both of them are important for peace, because I think the more knowledge people have, the more they know about each other, our different starting points, then the more tolerant we will be, and the less fights there will be in the world.
Your discovery, if I would say in a simple term, it's like a discovery of location system in the brain, right?
Yes.
That the brain will tell people where they are.
Yes.
So you prepare to talk about the sense of place and time.
Yes.
Is that something, when we talk about sense of place and time in our brain, I think most people can't help but think of the effect it gets, like when it comes to dementia or Alzheimer or something like that. Would your discovery will lead to some kind of treatment or some kind of prevention?
Yes, in the long run, I think so. So the discoveries are fundamental in the sense that it is about how the normal brain works. It's about the principles for how neurons or brain cells work together to create thoughts and feelings and plans, and also make us find our way. But it so happens that this part of the brain, which has this navigation system, is the very same part of the brain where Alzheimer's disease usually begins. So that's where the cells start to die first. And that's why one of the first symptoms of Alzheimer's disease is that you start not finding your way, you get lost, and also start forgetting. So I think what that means is that we are studying a system which is critical in the development of Alzheimer's disease. So I think that when we understand how this system works, it will be easier to find out what goes wrong in the process that leads to Alzheimer's disease. And then eventually it can be stopped before it is too late, because this process that leads to Alzheimer takes many years. So it's still quite a lot of time. And in the future, when some cure becomes available, you can give the cure at the point when you know the process has started, but it's still long before it actually results in any symptoms.
So we can detect it early.
Yeah, you can actually already now quite often detect it early. I mean,
like before you have symptoms.
Yes, but you can't necessarily do it at the level of individual people.
Right.
But what you see is that, first of all, there are some proteins that you can pick up in not in blood sample, but in fluid from the brain, and you can see that if those proteins are toxins are more common, then it is likely to result in Alzheimer, but that's already quite late. Another thing is that you see that this brain area that contains these navigation cells starts to shrink, maybe even 10 or 20 years before you start to really get symptoms. But this is when you average across many, many people, so you can't use it in an easy way today diagnose. What it tells us is that we know already that there are these symptoms. That means you can detect it early. The problem then is that still today we don't know really what to do. There's no cure that you can just give a drug and then you're fine. But that will come. But then you need to understand more. What is it that goes wrong in the brain? Why do the cells start to die? And I'm sure this will come, but we aren't quite there yet.
I think the interview you gave several years back, you were talking about you're trying to find out how spatial cells work in the brain, right?
Yes.
Is it something that you're working on now, or your research is on something else?
Yes, still part of what I'm working on now. So in the early days, when we did the work that resulted in a Nobel Prize, then we could only study one cell at a time. So we could record electrical activity from single cells, and then we could see that, oh, this cell is active only when you are in this or that part of the room. So it's a kind of a part of a map. What you can do today, which you couldn't do then, you can explore how all these thousands of cells in the network work together. How do they work as a network? What is the collaborations between the cells? Makes the brain know that you are here and not there. And that's where we are today. But in addition then to studying how space arises in big networks of neurons, you're also looking into mechanisms of time. So how do you get a sense of time? Whether is it a long time? Does it feel long or does it feel short? Does the brain have a mechanism for tracking how much time has passed since something? And both of those are elements of memory. So space and time, they are elements of most of the daily life memories. So for example, before I came to this room, I took the elevator up, and I remember that where I came from, somewhere down on a different floor, and took the elevator up, and maybe felt like it took a minute or two or something. So these are parts of the memories that we form about things we experience. And therefore I think both space and time, they are fundamentals of our experience that I still will keep me interested for many, many years.
Talking about your interests, I remember one of your interview. You said that your interests were actually, there was a point in time that focused on volcano.
Yes. Yeah,
what got you back into the brain?
Well, I never did any research on volcanoes. I was just interested in it, but that was more like a hobby, I would say. So,
is it still your hobby now?
Yeah, it is a while since I've been on an active volcano. It's a few years ago, but probably it was before COVID, so now it's a long time.
That was funny. How life would be probably such a different path if you decide to just go with volcano, right?
Yeah, no. So that's actually quite. Sometimes it feels a little bit arbitrary whether you end up going this way or that way, and it can lead to completely different lives.
I have to ask this. When you do research, they will talk about the different of research subject will be the condition of the person itself, the age group, and also gender, right? Yeah. The way the brain works scientifically. Yeah. Is it different from men to women?
Yes, of course. Brains are, I would say mostly similar, of course, very similar, but there are a few differences, and those differences account for the fact that males and females behave slightly differently. We are good at slightly different things, so some things males are better, other things females are better, and we emphasize different things, and that's biological, right? So there is a neural basis for much of that, but I think by and large, I would still say that the big picture is that things are very, very similar.
When I told my husband I'm going to talk to the Nobel laureate, he got Nobel from the discovery of the sense of space and time in brain and such. He's like, can you ask why men, when they say they always know where they're going, and the wife always doesn't believe them? I don't think it's something about how the brain works.
Yeah. Well, I think there is a long tradition of thinking that males are better than finding their way than women. And that is partly true and partly not true. Both humans and also animals, you can find it even in rats and mice. Males are slightly better if you average.
Oh, really?
But wait, I'm not finished. Slightly better when it comes to a type of navigation where you use landmarks that are far away. So let's imagine mountains or valleys or the stars. But then there are other kinds of navigation where you have to use more the more closer, the more proximal or nearby landmarks. So that there are tests that have been done where you test males and females in a forest where you can't really see the mountains behind. And then in some of those studies, women are better.
Wow.
Yeah, because it depends on what you focus on. So
Right.
I think you can't just say that one is better or the other. It depends.
Depends on the conditions,
Exactly.
the circumstances.
Yeah.
That is funny though.
Yes.
So you're working on now. What are you working on now? What do you hope to discover next?
The most interesting at the moment is how thousands or tens of thousands of cells work together. How can they create something that you can't see in individual cells? And we use that to understand space. How do you form a neural map of our own position? But I think in a broader sense, this is also a way to find out what are the computations that the brain does. So what are the, often we call them algorithms, what are the rules that the brain uses in order to calculate something? And that we study it on space, but it may also be on any other cognitive functions of the brain. That's what I find most exciting, because I think the space system, or the ability to find one's way, that evolved very early in evolution, because every animal is dependent on it. You can't survive without, right? But the brain usually recycles things that it has invented, because you can use it in a slightly different way to achieve something else. So that's the way evolution works. And for that reason, I think using space is a way into how the brain works and how it codes information. But that information may be relevant for cognitive functions that are much harder to understand, like thinking and planning, imagining, dreaming, all these things that are much harder to get access to.
I have to ask this, as a scientist, what do you think about artificial intelligence? Do you use it to help with your work or daily life also?
In some sense, yes, because we study very large sets of data, and we have to find patterns in the data. So we use techniques to train networks to learn from their own performance, to find patterns in the data. So we've done that for many years. But now artificial intelligence is evolving so fast that we are, in a way, a little bit behind.
Oh.
But I think it will come. And
what do you mean by a little bit behind?
Well, the techniques are there, but we have to learn how to live with them and how to use them.
Okay.
How can we best use artificial intelligence in research to maximize the information we can get out about the brain, for example? And this will come, but I think artificial intelligence will become a very important tool in research, which can help us. But we have to be also somewhat critical, because sometimes AI does big mistakes, right? So we can't just take it. We have to keep a critical mind and make sure that it just doesn't completely go off track.
How do you know when it makes mistake in research, though?
Yeah, that's hard. So I mean, that's what humans can do. You can say this makes sense or doesn't make sense. So it's usually because it's consistent or not consistent with things you already know from experience. The fact-checking is very difficult. So I think AI can in some way do it by itself, but in other ways, I think by living a human life, we have long experience where you actually can sometimes tell right from wrong just based on almost intuition, because we have learned it over the years and know what is likely to be true and what is less likely to be true.
Okay, yeah, at the end it needs a human touch.
Yeah.
anyway.
Yeah.
Okay, thank you very much for the time today.
Okay, thank you.